A symmetric number of another number is the number where the digits are reversed. For instance, 321 is the symmetric of 123. So 321 becomes as symmetric to 123 or vice versa. Similarly, 589 will become 985. So basically we are reversing the digits to find out what is a reversed number, symmetric number. Thus the difference between the number and its symmetric number must be divisible by which of the following? In such questions, what I intend to do at first is, since we already have an example of 1, 2, 3 and 3, 2, 1. So what I'll do first is, I'll subtract 1, 2, 3 from 3, 2, 1 and I see that what is the difference that I'm getting here. So let's quickly subtract. So I have 198. The question is the difference of these two numbers is divisible by which of the following number? 198 is not divisible by 4, so A option is out. Not divisible by 5 either, so B option is out. 198 is divisible by 6, so I'll retain it. 7, it's not divisible by 7, so it is out. And 9, the sum of the digits is divisible by 9, so we also retain it. So far, we have only two options left, which are option C and option E. Now, the second attack on the question will be to analyze what is the difference between these two options left based on which I would like to eliminate another option. So I see that one of them is even and the other one of them is odd, and so far the result that I've got is even. So now we have to think, is there a possibility that the difference of the two symmetric numbers is not even? Then the answer is yes. If I take a number such as 2, 1, 3 and then 3, 1, 2, then the result is not even. Understand, taking these values is a smart thing, and how have I been able to do that? The answer to that is that since when we exchange the numbers, when we reverse the digits, then this digit goes to the hundreds place and hundreds digit goes to the unit place. So we understand that the difference of these two digits should itself be odd. So I took one of them even and one of them odd. If we take the difference here, we can see that here we have 99. That means this is divisible by 9 but not by 6. So the answer becomes option E. That is one way to answer the question. Let me call it method 1. Now, there are two more methods that we can discuss quickly and understand the merit of them as well. Method number 2 would be to quickly see, does the question mention anywhere about the constraint of the number of digits in symmetric number? And the answer is no. And when we know then there is no such constraint available, then why not choose a number of just two digits? For example, let's choose a number 12 and its symmetric number 21, and the difference of these two numbers is 9. So we straight away reach to an option E. That's what I'm calling method 2. However, it's not much different, but the very important and special part about this method is to look at what is not given in the question. And since there is no constraint about the number of digits in the number is given, therefore we could also have chosen a two-digit number. Now, let me discuss third method, which I don't prefer much, but for the students who are learning, I think it's really a desirable method because it shows the algebra behind the answer. So if I take any number, if I take any two-digit number, let's say AB, and if we reverse the digits, then the number becomes BA. Understand that any such two-digit number can be written as 10 times of A plus B, which means if I have a number, let's say 57, we can always write it 10 times of 5 plus 7. If I have any number 93, we can write it 10 times of 9 plus 3. So AB number can be written as 10 times of A plus B. Similarly, BA can be written as 10 times of B plus A. Now, since we have to take the difference of these two numbers, so what if we take the difference? So on the left hand side, we have AB minus BA. On the right hand side, we have 10 times of A plus B minus 10 times of B minus A. So we are left with 9A minus 9B. That means 9 is taken common, A minus B. And that is how we get that the result is always divisible by 9, and that gives us answer option E. So method 3 is quite useful method to understand the algebra, because sometimes it might be useful as well. If you want to apply the same thing for the 3-digit number, that's absolutely fine as well, because you can write ABC. The symmetric number will be CBA. ABC can be written as 100 times of A plus 10 times of B plus C, while CBA can be written as 100 times of C plus 10 times of B plus A. If you take the difference of these two numbers, we are left with, see, 10B and 10B will cancel out each other. We are left with 99 times of A minus 99 times of C, that means 99 common, and we have A minus C, and it's once again divisible by 9 and not by any other number as such in generalization. So the answer once again is option E. I hope that helps. To build the concept, we need the algebraic expression, but we need to be smart enough to deal with the options and quickly figure out some deficiency if there is any, like explained in method 2. Thank you so much for watching this video.